Good afternoon, esteemed delegates, ladies and gentlemen. Now we come to the grand finale and the very last feature of the INAE Annual Convention 2021, wherein presentations shall be made by award winners of Young Engineer Award and Young Innovator and Entrepreneur Award for the year 2021 in two parallel sessions on their significant scientific and contributions that have been recognized and awarded. The presentations shall be held in parallel sessions as specified in the morning session. Award winners of INAE Young Engineer Award 2021. I invite Mr. Pankaj Malhotra, Scientist, Tata Consultancy Services, Mumbai.
Hello everyone, my name is Pankaj Malhotra and I am a scientist at TCS Research and part of the Deep Learning and Artificial Intelligence Research Group. First of all, I would like to thank INAE for giving me this opportunity to talk about my work. So over the next 15 minutes or so, I would like to talk about my work on data-driven methods for system health monitoring and prognostics. The aim of this work is to develop solutions to aid engineers in real-time monitoring and optimization of complex systems. To begin with, the motivation for this work comes from the fact that Internet of Things technology has made it possible to collect very large volumes of data pertaining to equipment behavior and that too in near real time. So this is done via various kinds of sensors installed on equipment, resulting in multivariate time series data. So this data can provide very useful information for analyzing the behavior of equipment. And such an analysis can help reduce system downtime, reduce the maintenance costs by intervening at appropriate times, and such that the timing of intervention is neither too early nor too late, and so on. So the vision of this work is to use data and technologies such as machine learning and deep learning to develop automated tools that can aid engineers in faster detection, diagnosis, and prognosis of malfunctioning of equipment. So to begin with, we focused on developing and testing our methods on publicly available data sets, and then tested these on industrial scale problems where data sets were collected and provided by various TCS's customers. Um, so the key idea of this work is to basically that given any multivariate time series of sensor data, so we first try to model the normal behavior of the system. Once we have a capability to model the normal behavior of the system, then any statistical deviation from this behavior indicates a potential malfunctioning of the system and serves as a starting point to subsequently detect, diagnose, and prognose abnormal behaviors. So in this case, contextual knowledge is indispensable, and so most of this work is interdisciplinary in nature. And I would say that the collaborations across domains has been crucial to the success of this work. So moving on, the key novelty of the approaches that we have developed over the last 5-6 years lies in the ability to identify and address practical challenges that we came across due to our close collaboration with the industry. So some of the key features of the methods that we have developed are listed here. So we have developed approaches that can deal with a very large number of sensors simultaneously. So we have been able to successfully test our methods for up to 50 odd sensors. The key advantage here is that by modeling all sensors simultaneously, we are able to capture various interdependencies, both across time as well as across sensors. So the methods we have developed are domain agnostic in nature. In industrial settings, it is important that whatever methods we develop scale and work across various use cases with minimal dependence on subject matter experts for things like feature engineering and so on. So now, given that our methods often use deep learning models at their core, they are capable of processing very large volume of data, and that too in a domain agnostic manner. So moving on, so most practical applications involve dynamical systems that evolve over time. It is therefore very important to take into account this factor while developing the method. So we have in fact developed a number of techniques for handling issues in dynamical systems such as non-stationarity, then noisy nature of the sensor readings, and even uncertainty estimation in the estimates from the models that we develop. So I'll talk about this in a while in a bit more detail. More recently, we have started exploring this, I would say, rather important aspect of leveraging readily available domain knowledge. So what we have observed is that for most equipment, the system level diagram is almost always readily available. We have proposed an approach to leverage this very precise form of domain knowledge to improve the performance of our models, especially when the number of sensors involved is very large. So I'll again go into a little bit of detail about this. And all the methods we have developed have resulted in over 25 publications at peer-reviewed international journals, conferences, and workshops. And these methods have been integrated into TCS platforms such as TCS Industrial Twins and TCS Connected Universe platforms. And so the kind of applications or systems where we have evaluated these methods include turbofan engines, automotive engines, large subsystems of a power plant such as pulverizer mills, gas desulfurization unit, PCP pumps, valves, uh, iron mill etching tools, and so on. So what I want to do next is give a high level sense of the kind of methods we have developed to address the challenges that I listed down in the previous slide. And so I'll keep it at a high level without going into too much of details in interest of time, but I would be happy to take any questions during the Q&A or offline over email. So the first challenge I want to talk about is how do we monitor and model data from a large number of sensors in a complex system. So the idea here is to leverage dimensionality reduction within neural networks, but still keeping it end-to-end trainable via backpropagation. So we achieve this via regularization and suitable inductive biases in the neural network architecture. I'll skip the maths here. So what I want to highlight is the kind of impact this can have. So our approach, which we refer to as spread, so short for sparse neural networks for anomaly detection in multivariate time series, is that we are able to show better performance than several anomaly detection benchmark methods. And in fact, this approach is very close to the upper bound relevant AD, which is essentially the approach which knows upfront that the anomaly is in which sensors and then uses those sensors to detect the anomaly. So of course, this relevant AD kind of an approach is not possible in practice because a different subset of sensors would depict anomalous behavior at different time steps. And that is where our approach, without any knowledge of which sensor has the anomaly, would still work and in that sense depict scalability. So one post facto study that we did confirmed that we could detect anomalous behavior in one particular sensor given data from 39 sensors from a pulverizer mill, and our approach could detect the anomalous behavior, which eventually would have led to an abrupt shutdown of the mill due to failure. And this was confirmed by the domain experts as well. So moving on, so the other application is how we handle noise in sensor data for equipment health monitoring. So this particular approach that is shown here is for prognostics application, where the goal is to estimate the remaining useful life of an equipment given sensor readings over its life cycle. The key idea here is to do the comparison of an estimate of an engine's current health trajectory with other engines or equipment which have already failed in the past and for which we know the total life, and to do this in a learned representation space rather than the original sensor data input space, since the representation space is smoother and robust to noise. So we tested our approach on two data sets. One of them is a public benchmark dataset released by NASA related to turbofan engines. And another one was a dataset from a TCS's customer related to pumps. In both cases, we saw that comparing the equipment health in the latent representation space was better than comparing the health in the input space. And what the table on the bottom right shows is that as the noise in the sensor data increases, the model comparing equipment in the input space, referred to as Recon RUL, degrades abruptly, while the one using latent representations, which is referred to as embed RUL, degrades more gracefully in terms of timeliness score, which is a standard metric used to evaluate remaining useful life estimation model. And so moving on, so this is one of our latest works wherein we try to leverage the structure of an equipment to guide the architecture of the neural network itself. So the key insight here is that if we process the sensor data for each subsystem independently and then combine the processed outputs of these various related subsystems, then we can potentially do better modeling of the overall complex system of systems. So here, each module of the neural network can focus on first modeling a particular subsystem before it goes on to exchange the processed information with other subsystems. So we achieve this through graph neural networks, and we could in fact show state-of-the-art results on 4 different variants of the again the NASA's turbofan engine dataset. Moving on, so another interesting application I wanted to just briefly touch upon is related to process optimization. So the setup is that several process optimization exercises are typically carried out over a period of time across different installations of the same system. And the goal here is to reach an acceptable range of various operational parameters by arriving at a feasible setting of the control variables in as few trials as possible. So this potentially not only could save time, but a lot of manual as well as raw materials cost. So in this work, we used meta learning for learning to optimize itself. That is to learn how to quickly solve a new optimization problem given prior experience in solving similar optimization problems. Right? So just to kind of quickly talk about the impact. Uh, so this work that I spoke about has been, I think, received very well in the research community. Some of our initial papers, in fact, I would say opened up new line of research in the industrial IoT analytics space and even beyond, as indicated by over 2000 publications on this topic. over 2000 citations on this topic for our publication in the last 5 to 6 years. And this work has led to 3 journal publications, 10 conference publications, and 8 workshop publications in the last 5 years. So 19 patents have been granted across geographies, including US, Japan, Australia, Europe. And so 3 of our published papers have reported state-of-the-art results for time series classification, diagnostics, and prognostics applications. Uh, so our team stood third in an international data challenge organized by the International Prognostics and Health Management Society in 2018. And so as I gave glimpses into it, so we have done several proof of concepts for customers across geographies. And a lot of this work has gone into offerings from TCS, including uh, TCS Industrial Twins or InTwin and TCS Connected Universe platform. So just to summarize, so there has been an exponential increase in IoT-enabled devices, resulting in vast amounts of data and real-time automated monitoring of systems. I would say still remains an open challenge, and our work tries to address many of the practical challenges in this context that are at least at present in a position to assist humans in making better informed and timely decisions, if not fully automate the entire pipeline. Last but not the least, the methods that we have developed over the years are largely domain agnostic in nature, due to deep learning being a main component of these. And these have, in fact, been adopted in several other domains, such as medical, healthcare, cybersecurity, utilities, smart cities, etc., both within TCS as well as by others in the research community. So one future direction that I am really excited about is how to bring in the knowledge of physics of the systems into designing of these models. So the graph networks approach I spoke about is, I would say, a step towards that, but I think we still have some way to go before we have approaches that are consistently more reliable and adhered with the theory of the systems and work with the potentially reduced amounts of data. Before I end, so I would like to thank all the wonderful collaborators without whom this work would not have been possible. Thank you.
Thank you, Mr. Malhotra. I invite Dr. Abir De, Assistant Professor, Indian Institute of Technology, Bombay.
Abid. I'm an assistant professor in the Computer Science and Engineering Department at IIT Bombay. So I'll be talking about machine learning under triage. So triage in clinical sense means that it's a decision process about making the order of urgency about the treatment, okay, treatment of different patients. So here we'll use triage to make decisions about different tasks. So depending on the urgency, we want to outsource some of the tasks to humans so that the rest of the tasks can be assigned to machines, so that the overall accuracy achieved by human and machine is superior to what they could have achieved together. So to give an introduction, we are entering into an era of artificial intelligence. However, the society still rely on human experts to take decisions, which has especially significant consequences. For example, judges are the final decision makers in judicial dispute. Doctors diagnose disease rather than any kind of softwares. Hiring managers still rely on experts to make decisions about candidates rather than the softwares. Similarly, about loan analysts making decisions about providing a loan to someone or not. So in all this context, it is true that these experts take cues from the softwares or probably machine learning or artificial intelligence model, but it is still the fact that they are the final decisions makers in this context, especially because they have significant long-term consequences. So because that, one has to take some responsibility. You cannot rely completely on the softwares to make decisions about. However, the timeliness and the quality of the human decisions are often compromised by two factors. The first is the large number of decisions, and the second is shortage of human experts. For a very developed country like Germany, even the average waiting time is approximately 33 days for an eye examination. So we could see that the timeliness and the quality of human decision makings are often compromised if human are the sole decision makers. And what about the machine learning models to solve these problems? Indeed, there has been a lot of effort to do so. However, we see that machine learning models is sometimes even worse than human in high impact applications. For example, in estimating severity of diabetic retinopathy, we observe that in 40% cases, machines are worse than humans. Okay, so in these 40% cases, we could end up giving a wrong diagnosis to the patients, which is not desirable in particular. So can we train a machine to take decisions for some of the cases while outsourcing rest of the points to rest of the samples to humans? So the task is that we are given a feature space like this, and some of the samples should be outsourced to humans, the special experts, and the rest of the samples should be outsourced to machines. So our goal is to develop machine learning models here, which will be able to take decisions for a fraction of instances and then leave the remaining ones to the humans. So if you think about AI or machine learning, the purpose of AI and machine learning, they usually the key purpose is to automate a decision making process, right? And here we still involve a human in the decision making process, and therefore it's basically machine learning under a partial or controlled automation level. So if we let the machine to take decision about all the samples, then we certainly observe that in some cases the decision is that in some cases machine perform poorly. But what about, for some samples, bring human into the picture so that human takes care of some of the samples, so that the overall accuracy obtained by human and machines is superior to what human and machine could have achieved at an individual level. Okay, so we consider a simple setup for support vector machine in this case. Okay, so we are given a sample. So this is the orange samples, a positive samples, and the green samples are negative samples. And we want to defer some of the samples to human by training a machine model, which is a support vector machine. It's a simple linear SVM model, so that the human and machine performing together gives a superior performance to the machine model or what human could have achieved. Now, a simple technique would be like this, that you train the machine using all examples, okay? And now anticipate at which points machine is going to perform poorly and outsource only those points to humans. So outsource only those samples where the machine is likely to incur more error. So you could see that these are the wrongly classified points, because these orange points are on the green side and the green points are on the orange side. So they're wrongly classified, and if you anticipate them, then you give them to human. And the rest of the points you outsource to the machine, provide to the machine. So basically, you could see you train the model using all the samples, you outsource the points which are wrongly classified to the humans, and okay. And for the rest of the points, you make the machine to take, you ask the machine to take the decision about. Now, if you carefully observe, the machine is not aware of the presence of human in the training time. So the classifier that the machine model here is not optimized during training. So basically, you know that there is a human in the picture, but you did not reveal this setup to the machine during training. And the machine assumed that I have to take care of all the samples, so I will be robust enough to take care, even the wrong samples and so on. So the machine somehow performs suboptimally. And during test time, it observes that, oh, there is a human to take care of all, but I did not know that during training. But that's how it works. And unfortunately, this is suboptimal. Simply because if you carefully see, the machine model is basically trained on the entire samples, and it is supposed to take decision about those points, but you now ask the human to take about these decisions, and therefore the machine which is now not aware of the decision-making process during training, will perform suboptimally even on the points on which it is supposed to take decision during the test time. For example, if you look at these points, this boundary region, you could see there is some orange points are misclassified. But suppose that machine would have known that I would only have to take decision about these points, then it could have been trained better. Okay. In other words, if we somehow magically anticipate that these are the points that are being going to be outsourced to humans and let machine be informed about it, then the machine said, oh, these are the points I don't have to take care. So I will not even get trained on this in these points. I will be trained only on those points which are the potential points on which I'm going to make decisions about. Right. In a consequence, this model is actually optimized during training itself. Okay, and therefore this machine becomes aware of the presence of human during the training time. Okay, so to come formally into the problem, so here is a simple problem formulation. So we want to minimize the training loss. Now we don't know what are the samples that are going to outsource to humans. So here, along with the machine model, the candidate set which is going to be outsourced to human is also the optimization variable. Okay, so basically this loss has two parts. One is the machine loss, another is the human error. Okay, and this human error is available during training. And then you train the samples assigned to humans, that is this candidate set S, and the rest of the samples is assigned to machines, subject to the condition that the maximum number of samples that can be assigned to humans is less than or equal to n. Now, the key point is that you know that this problem can be solved by some manner, suppose, during training. And during testing, it is very difficult to find S, that is which samples you are going to outsource to human, because to compute S, you need to solve this optimization problem. And this optimization requires yi, that is the true levels, which are not available during test. So what you do, you assign a new level d plus 1 if a points is outsourced to humans, and d equal to minus 1 if the points is outsourced to machine. And then you train an additional classifier on the feature and this new decision variable. And finally, you have an additional classifier. Now, if you receive a new sample in testing, a new test sample, you pass first to this additional classifier. And if this test d becomes 1, then it is decided by machine. And if d equal to minus 1, if d equal to plus 1, it is decided by human. If d equal to minus 1, it is decided by machine. So whenever it is d equal to minus 1, you send this sample to the trained machine, and you finally get the level predicted by this trained machine. Okay. Okay, so now the question is that how to solve this optimization problem. Okay, so the simple way to solve this optimization problem is, it turns out this problem is an NP-hard problem, and therefore we observe some special property in this objective, which is turns out that for context losses, this objective is monotone and approximately submodular, and therefore we apply a greedy algorithm which gives us approximation guarantees. So basically, this objective, which is a negative of this condition, is a monotone and approximately submodular. Approximately submodular means that it doesn't exactly follow the law of diminishing returns, but it's approximately, it approximates that formulation of, marginal gains or diminishing returns. So that's why we say this is an approximately submodular, and therefore this such condition allows us to use the variance of greedy algorithm, which with approximation guarantee. Okay, so now coming to the coming to the experiments, we actually take Messidor, which is a data set of diabetic retinopathy, and then we actually change the automation level from basically high to low. Okay, so here this means that it's full automation, that is no points is outsourced to human, and you try to increase this numbers n, which means that you outsource more points to human. That means that you are decreasing the automation level. And we observe that predominantly our method is performing better than most existing models, which actually, which actually try to solve the problem from the point of view of like human unaware machine model, machine classification. For example, the setup that I initially discussed, that you train the model using entire samples and then outsource samples which incur more loss to the human. So these are the variants of them. That is the orange and blue points. Okay, and we observe that our model is performing better in most of the automation regime, and especially for 16% samples, if you want to outsource to human, you observe that our model performs best. So to get a more more insight, we try to observe that we try to investigate that which samples are outsourced to humans by our model. So we observe that our models actually automatically detect, our algorithm automatically detect difficult samples and then it outsources to humans. So here you consider there are two samples. Okay, one is the easy sample, one is the difficult sample. Why you are saying difficult samples? Because this is a case of identifying image with diabetic retinopathy. Okay, however, it turns out that this image is basically targeted towards identifying the Duchenne disease, which has characterized by pathological yellow spots. But turns out that this image has a pathological yellow spot, but it is not a Duchenne disease, it's a diabetic retinopathy. It turns out that our algorithm actually identifies that and then it outsources to humans. That it is not at least the Duchenne disease. It says that, okay, it still has pathological yellow spot, but it is not about Duchenne disease. So it outsources these samples to humans. So we see that, despite having this yellow spot, the model somehow detects that this is not Duchenne disease, this is something wrong, and I'm not going to take care of it. Let's the human take care of it. Okay, so this is all. So we have in this work we have focused on independent samples, specifically algorithmic triage in sequential independent samples, and future work can be algorithmic triage in sequential decision making. Here we have assumed each instance is predicted by a model or by a human. But what about human being informed by a model? And finally, we want to adapt our model to the case when the ground truth is not available. Finally, I want to acknowledge all my collaborators, and I'm fortunate to work with them. They provided excellent insights to this work. And finally, I'd like to take questions if you have.
Thank you, Dr. Dey. I invite Dr. Abhijit Mohapatra, Assistant Professor, Indian Institute of Technology, Kanpur.
Hello, I'm Abhijit Mohapatra, Assistant Professor in the Department of Electrical Engineering at IIT Kanpur. I thank Indian National Academy of Engineering for this honor based on my work on novel dual conic programming based optimization of AC electric power networks with intermittent renewable energy sources and load injections. The objective of this work is to find risk-averse or robust, feasible, and globally optimal solutions for the operation and planning of AC transmission and distribution networks in the presence of renewable energy sources, while keeping the emphasis on keeping the computational time burden of the obtained solutions to the minimum. This objective is motivated by the fact that optimal power flow is an indispensable tool for the optimization of power networks. For AC networks or in general for power networks, the different types of costs are involved in generation as well as planning operate perspectives. Hence, optimization or OPF becomes a very important tool while trying to keep the cost to be minimum along with several other objectives, and also trying to satisfy and maintain the system's operational and physical constraints. Through the inherent nature of the AC network, the network physics, as well as the way the network operates, the AC OPF model, to be specific, is non-convex and non-linear. In current times, renewable energy resources are being integrated into the power network. The generation of these resources, it's uncertain and variable. Also, because of the dependency on weather conditions. Also, the network loads are uncertain and variable due to the consumer behavior as well as seasonal variations. Unfortunately, to date, there doesn't exist any forecasting algorithm that can provide 100% accurate forecasts. If such forecasting algorithm was available, then dealing with these uncertain and variable injections would not have been an issue. Since such an algorithm doesn't exist yet, so robust optimization has gained the interest of several researchers, in which one set of solution can be obtained for all uncertain and variable scenarios. Unfortunately, robust optimization theory is well explored in simple approximated models. It is not directly applicable to AC network optimization because of the nonlinearity and non-convexity of the model which replicates the AC electric network. The electric power industry also appreciates and understands the importance of obtaining these risk covers or robust solutions. Unfortunately, because there is yet not any guarantee that AC network optimization can converge in a finite real time. Hence, the industry also uh, uh, utilizes simple approximated or deterministic models. The problem with such models for the AC network electric network optimization is that majority of times the solutions for the AC network are infeasible. Even if they are not infeasible, additional reinforcement is required to make the solution feasible and economic, and hence such a brute force mechanism of operation doesn't help the system in system economics and security perspective. To deal with the AC models, non-convexity and non-linearity to some extent, second-order conic programming is a promising approach. The issue with conventional SOCP formulation or relaxation is that although globally optimal solutions are obtained, the solution obtained for the AC network is still infeasible because of the weak duality issue. So if at all this problem can be catered and strong duality can be enforced, then probably SOCP based modified formulations, conic programming formulations, can be used for the robust optimization of AC electric networks in Bender's decomposition. The key idea of the current work emerges from the fact that AC OPF search space is nonlinear and non-convex. E and F are the real and imaginary vectors of all bus voltage phasors. With SOCP, E and F are transformed into C, D, and S, and hence the overall search space, the constraints, they are linear. But because of transformation, two additional inequality constraints appear in for all network lines. In SOCP relaxation, the second tan constraint is ignored. The first constraint is relaxed as a cone, so overall formulation or solution obtained is convex and globally optimal. But because of negligence of second tan constraint, the formulation still doesn't give solution which is exact for the AC network and also has weak duality issue. To deal with this problem, the first idea was, can there be a guarantee to obtain feasible solutions from the modified SOCP formulation? So that was achieved and it has been well proven in these few papers. The second tan constraint is approximated as the linear inequality constraint. The problem of weak duality still exists because of the issues in the conventional cone dual theory. And that's where the second idea comes in, which helps in utilization of this model, modified SOCP model, for robust optimization of AC power networks. I have used the Lagrange cone-based dual theory for the optimization of robust optimization of AC networks, and there is a guarantee that strong duality is possible through the use of basic constraint qualification. Few typical results from this work, they would be presented in the next few slides. The result in this slide verify the efforts that have been made for the first computationally time efficient methods that can give feasible and zero optimality gap solutions from the SOCP formulations of AC electric network. The figure here shows the comparison of three SOCP formulations with the industry-grade DC model solution. The SOCP2 formulation has absolutely zero optimality gap with no percentage violations for the actual AC network, whereas that for the DCOPF model, which is the simpler and the approximated model, case 24 and case 73 solutions don't work for the AC network, and hence optimality gap and violations are very high. The computation time of SOCP2 is comparable to the DCOPF solution, and hence there is a possibility that strong duality and globally optimal feasible optimization AC optimization solutions can be obtained in real time. These two figures here show the feasibility of the solutions obtained in terms of voltage phase angle differences for different test cases from SOCP2, whereas this figure indicates the validates the fact that the line flows, they all satisfy their operational constraints for the NRPG 246 bus system. The table here shows the importance of using the proposed Lagrange dual theory as compared to the conventional cone dual theory CDT. CDT fails to give a feasible solution for one of the test systems, or in fact in other test systems the objectives are very high for the planning problem, whereas in the proposed dual theory the solution is exactly same as that should be expected from the primal problem. This slide here shows the efficacy of obtaining robust solutions from the combination of ideas 1 and 2 for AC power networks. The table here shows the attributes of the robust formulation for the operation of AC power network. The formulation is purely nonlinear AC in nature with a robust counterpart. Number of levels involved in decision making is 1. The optimization model is convex. There are no integer variables. Budget of uncertainty considerations have been done to reduce the conservativeness of the solutions, and the solution procedure is non-recursive as compared to other non-robust and stochastic optimization papers where the computational burden is very high. In terms of the planning problem, the proposed formulation is nonlinear AC, has its roots from the mathematical classical optimization theory with due consideration to all network injections, whereas majority of industry grade work or even in the literature, the basis is still on the use of the DC simpler model with applications from the meta heuristic algorithms. This table indicates the efficacy of the proposed formulation in terms of low computational time and 100% robustness of the obtained single plan, as compared to stochastic formulation, where for one test system the efficacy is 95.16%, whereas for other test systems when it is tested it falls below 85%. The figures here show the plans that have been obtained, the transmission expansion planning solution that has been obtained for the Garver 6 bus system with renewable energy resources, conventional generators, loads marked as arrows, and a base topology of lines available. 3 different solutions have been obtained from 3 different frameworks. The first one is the deterministic simpler ADC model. The other one is the deterministic AC model, while the third one is a robust AC model using the proposed robust optimization theory. The solutions have been obtained and they have been tested for 4 typical scenarios created by the loads max, min, and renewable max and min combinations. It can be seen that the last figure here has all the lines and buses or injections in green color, indicating that there are no problems in the solution that have been obtained. The system is feasible, operational, and everything is perfectly good. Whereas in the other 2 solutions, there are red colors indicating that there is some voltage violation at a bus or some injection curtailment or some line flow violation. Although the robust solution has a costlier plan as compared to the other 2 plans, but the cost that has been incurred still doesn't guarantee or still doesn't overlay the fact that robust solutions cannot be obtained from the other 2. Similar solutions have also been obtained for the operation of the AC transmission network as well as active unbalanced distribution networks. At IIT Kanpur in the Smart Grid Control Center, I and my group of colleagues and students, we are working towards the first in-house development of the active distribution management system, thanks to a Indo-US project and a core research grant project. The ADMS platform, once it is available, once it is ready, it would help in efficient energy management and reliable energy management of the urban and rural distribution networks with renewable energy resources. These would help the customers, the power customers, in the sense that load curtailments would be at the worst case minimum possible, with proper guarantee or surety of good power, good quality of power supply. Several ADMS functions are being developed. Some of them have been listed here, starting from power flow optimization, volt for optimization, network reconfiguration, and loss minimization. The first few they have already been implemented as plug and play modules on the existing SCADA network. The other two, they are under the process of implementation, and once everything is ready, we are the algorithms or the functions would be implemented on two IITK residential lane feeders, which would replicate a urban feeder and a rural distribution network with several renewable energy resources connected to it. To summarize my presentation, first few attempts have been made for computationally time efficient and tractable algorithms that can provide feasible, robust, and globally optimal solutions for the operation and planning of AC electric network with injection uncertainties. The algorithms, they have a good theoretical and mathematical basis, unlike non-robust or stochastic programming algorithms, which are mostly like black boxes, and the electric power industry is very wary of those algorithms. The performance and the real-time implementation have indicated that these algorithms, they are executable in real time with ensurity that system feasibility is always ensured, and they can work well for large practical networks. Once with these algorithms, they would be extremely useful to the planners and operators at CEA and POSOCO and other state level utilities. The consumers would also get benefited from such algorithms in terms of minimum load curtailment, good quality of power supply, and efficient energy management in terms of minimum tariff that they have, minimum bill that they have to pay towards their electricity consumption. I'm also working towards extending the current ideas into other ADMS functions, as well as towards power network protection coordination. Last year, one of my papers on robust optimal transmission switching was judged as one of the best papers in 2020 IEEE PS General Meeting, which is one of the renowned conferences in power and energy research area. I have also received the Devendra Shukla Young Faculty Fellowship for my work that I have been doing for last few years here at IIT Kanpur. Thank you for your time and patience.
Thank you, Dr. Abhijit. I invite Dr. Manus Kumar Jaina, Assistant Professor, Indian Institute of Technology, Palakkad.
Hello everyone, my name is Manus Kumar Jaina and currently I am serving as an Assistant Professor at IIT Palakkad. So the topic of today's presentation is Synchro Phasor measurement based applications for enhanced control center operations and power system protection. Coming to the research motivation, it is observed that protection system maloperation along with lack of adequate situational awareness kind of major causes behind most of the cascade activities leading to blackouts in the power systems. Coming to possible solutions, use of synchro phasor technology for enhanced power system monitoring, control, and protection is one of the solutions that operators are looking for. Why this is the case? Because with the use of this technology, the operators can now observe and react to grid dynamics, which was not previously possible with the traditional SCADA technology. As far as my engineering contribution is concerned, I've divided it into two parts, two categories. One is contribution to product development, and the other one is contribution to engineering research. So as part of GE General Electric's WAMS team, wide area measurement system team, I did contribute to the design and development of this offline engineering analysis software solution for phasor analytics. Coming to engineering research, I also suggested solutions related to BOMS technology, which can enhance power system monitoring as well as power system protection. In the right side, I have shown you some of the use cases related to phasor analytics software solutions, event analysis, model validation, calibration, and oscillation baselining. They're very important applications, and each of these use cases you can see is having its own key driver. For example, model validation and calibration, its key driver is NOR guideline mod 26 and 27, which mandates power plant model validation. So continuing with the discussion of phasor analytics, with the use of the software solution, operators can not only analyze phasor data coming from pumps, but also measurements coming through SCADA and data from the simulation, fault recorders, so on and so forth. And we have modules for data management. There are base applications such as data trending, predefined calculations, and then the advanced applications such as oscillation baselining, post-event analysis, and model validation and calibration. Similar to phasor analytics, at the bottom you can see this is the GUI of the in-house developed software solution at IIT Palakkad, and we are calling it BigSync, Big Data Analytics on Synchro phasors. So again, the objective is to come up with similar solutions, whatever is available in the market now from different vendors such as GE, Siemens, ABB, so on and so forth. So continuing the discussion on some of the applications related to phasor analytics. So oscillation baselining is one of the important applications. So in this figure, you can see that in near real time, operator will be able to monitor the most dominant modes that are observed in their system. For example, we can see there are modes such as 0.08 Hz, 0.22 Hz in that particular system. Using the WAMS technology, only they're able to observe these oscillatory modes. But then the solution also provide alert and alarm signal to the operator whenever it sees that any of the oscillatory modes is getting poorly damped. For example, you can see one of the oscillatory mode of 0.9 Hz is providing alert signal to the operator because its damping is going below a particular threshold. So thresholding is very important because as a software solution, the objective is to make sure that operators are not overwhelmed with false alarms. At the same time, the solution should make sure that any poorly damped oscillations should be informed to the operator. So that's where configuring triggering attributes is one of the most important tasks. And that's where this offline baselining study comes into picture. I have shown here 3 steps which typically we follow to make sure that the triggering attributes are reliable. So what we do long-term oscillation review, maybe 6 months of measurement, 1 year of measurement, then identify the subbands, where the modes are, what are the frequency of oscillations, and what are the measurements where these modes are observable, then use some statistics to come up with reliable resource. Continuing with the discussion, from the PMUs, phasor measurement units will get signals such as frequencies, angle difference, and signal processing is applied on those signals to come up with information related to certain modes. Typically, 2 types of windowing are used. One window uses a larger length, such as 20 minutes or so. The other one uses a shorter length, that means 3 minutes or so. Why 2 types of windowing? Because as I just showed in the last slide, in real time also we need to monitor the oscillations, and then we also need oscillation information for baselining study. So for baselining study, a longer window is used, and for online application, a shorter window is used, so that every 5 second, with every 5 second refresh rate, operator will be able to monitor the oscillatory modes of their system. And the outcome of this baselining study is something like this. It's called a histogram plot. That means in the x-axis, you'll have the frequency of those oscillatory modes which are observed in your system, and y-axis is number of observations. From this, we'll be able to find the subbands, and then this table you can see it's the final outcome of the baselining study. For example, let us say for subband 2, that is between 0.15 Hz to 0.28 Hz, the alert threshold for a damping ratio is 5%. That means if you have a mode in that particular subband, and in near real time, if the damping percentage of that particular mode goes below 5%, then the operator will get the alert signal. And that's how rest of the numbers are given. So coming to model validation calibration, another important applications, power plant model validation is very important. And now with the availability of PMO measurements, we will be able to do model validation and calibration without taking the machine or plant out of the service. So again, the idea is for a particular contingency or disturbance, the phasor measurement unit would have captured the measurements, the actual measurements, and in the control room, we have the simulation for the system, simulation model for the system. So how about for that particular contingency, the measurements which was captured by the PMU, compare the measurement with the actual simulation response. If my model is correct, we are expecting both to overlap. If that is not the case, then we need to identify the parameters which need tuning and then tune those parameters so that the model response will match the simulation response. The 3 steps are typically followed. Model validation using concept of force simulation. So typical example is given here where we can see the response coming from the measurement and the model are not matching or overlapping. That means the model is not valid. Then we do sensitivity analysis to identify those parameters which we can tune, and then do the optimization to make sure that the parameters are properly tuned. And then we will see that again run the simulation and see if the simulation response is overlapping with the response coming from the actual measurement. That's how this model validation and calibration is done. Event analysis and disturbance characterization. With the availability of high resolution measurement from the Synchro Phasor technology or through the BUMS technology, now we can use the signatures corresponding to each and every event in the power systems to come up with event classification and characterized module. For example, this typical example of an islanding system where we're expecting an over generation and under generation region, which will be reflected in the frequency signal. So another example can be, let us say, there is generation creep. It will have its typical signature of frequency drop followed by slow recovery. So this kind of physics-based rule is applied to come up with a solution where the tool will import the measurement, the synchro phasor measurement, and then it will try to detect if there is any event. If there is any event, then what are the signals or measurements where these events are captured, and what is the type of event, whether it is generation loss, load loss, islanding event, oscillatory event, so on and so forth. Same solution we have also integrated to BigSync, where again the user will be able to import the measurement data and then do the analysis and come up with the result for the event detection and classification module. Now, application in protection, I did mention about issues related to relay maloperations, and it is observed that loss of security aspect of the relay is very dangerous during stressed power system conditions. But at the same time, power system protection engineers are always more biased towards dependability. No faults should go undetected. So how about adaptively change the dependability security bias depending on the system stress conditions? So that is the philosophy behind this adaptive dependability and security based scheme. So here what we are trying to achieve is to make the bias more towards security aspect of the relay during stressed power systems condition so that it should not maloperate. And during normal conditions, it should be more biased towards dependability. So This is how we'll be able to make sure that relay maloperations are avoided during stressed power systems. Another application for transient stability prediction and stress assessment. Here again, this is another measurement-based application only. We are not using any model information. Using the PMU measurements, where we come up with some center of power-based indices, and then those indices are used as input to a machine learning model. So we have tried with various machine learning models actually, and decision tree based model, random forest based models, and then see whether the tool is able to predict the transient stability condition following contingency in the power system. So this is only measurement. The advantage here is it is based on only measurements, and this can actually predict whether the system is going to remain stable or unstable following a contingency, and this is also integrated into the mixing. Coming to the conclusions, the research conclusions resulted in the design and development of multiple software solutions which are being used to operationalize wide area monitoring system in the control room. The software solutions are deployed in control rooms such as ONS in Brazil. I did oscillation baselining study for two customers, that is ISO-NE and American Electric Power AEP, and Tenet is also using Phasor analytics. Design and development of innovative methodological approach to prevent relay maloperation during stress power system condition was also suggested. And finally, I did mention about the in-house software solution mixing big data analytics for synchro phases, which is again kind of an offline engineering analysis software solution, which can not only help the operators for online monitoring of the system, but also the planning engineers for model validation and calculation. Thank you.
Thank you, Dr. Manus. I invite Dr. Manan Suri, Associate Professor, Indian Institute of Technology, Delhi.
I'll be talking about what we are doing in the what kind of research we are doing in related to memories, to be more precise, semiconductor memory technology. So, this would be the outline of my talk, brief motivation. Then I'll try to cover a couple of specific examples based on how much time we have today. So, the basic motivation for this kind of effort lies in the sort of environment that we are living in, or that we are aiming to build around ourselves. Any sector that you take, whether it is IoT, smart cities, social media, defense and security, digitization of governments, anything that you take is predominantly takes us in the direction of extreme data or extreme information generation. So that is the more conventional motivation behind even looking into memory or storage or memory related aspects. And if trends are to be taken at face value, there are units known as new units known as zettabytes or 10 raised to 21. So we are just talking about huge amount of data. So things like 62,000 billion gigabytes. So not 62 GB or 62,000 GB, but 62,000 billion GB. So definitely the sheer quantum of information is one thing that pushes us to ask this question, that what are we doing with the methods and the means to store all this information around us. Like it takes us to more scientific or fundamental questions, that what kind of platforms or mechanisms we even have to hold this information, because at some point it does become physical in the real world, or in the electronic or the semiconductor world. Now, the other interesting aspect, what has been happening more recently, is something that goes beyond just the storage, beyond just 1 and 0 storage. And if we look at some of the present day applications that everyone is talking about, whether you refer to ML, AI, even the distinguished speaker before me mentioned things like classification and so on. This chart shows you a breakdown. It's from 2017. It shows you a dissipation map of what would happen if you run a deep network, if you try to dissect it. What you would see here is that about 22% of the dissipation is directly from the weights, and about 43% from the output feature maps, 25% from the input feature maps. And so all this amounts up to almost 90% and surprisingly just 10% from computation. So the motivation, the understanding of or how digital systems or computational systems have evolved over the years, primary emphasis on was on getting the compute power in place, on scaling the transistors, or getting the compute as efficient as possible. Now that is something which needs a revisit or an inspection, because the kind of application domain with ML, AI, or big data kind of computing that we are walking into, it so happens that when you do a breakdown of those, or when you dissect or look deeper into those applications, it turns out that memory starts taking a more center stage, all memory related actions. So this is another motivation why we are looking at these things, which is just beyond the simple numbers of storage, that how much more you need to store. Now let us look at one more trend, the outcome of conventional von Neumann computing, which isolates the processing and storage blocks separately. So these are some estimates which show you that if, just to give a sense, that if a typical add operation was normalized, the dissipation for an add operation in compute was normalized to 1x, the energy that you dissipate to send data off your main memory or fetch it back, that's almost like 3000x. So you can yourself, take a call that which one, if I want to design optimized systems or really efficient systems, what I need to focus on. Should I focus more on the optimization of compute, or really how data is managed, how data is handled, how it is fetched? And so again, what I'm trying to underline here is that there are multiple motivations which push us in the direction of really thinking deeply about memory. So far, it has been dealt with just one lens, that is like storing ones and zeros. And here we are making a case of going beyond that motivation. So another interesting thing that we also looked into our research is bio-inspired computing, or a niche area of bio-inspired computing that we define as neuromorphic computing or neuromorphic systems. And again, the inspiration here comes from the very little things that we know about processing in mammal brains. And if I were to, just abstract the key message given the time constraint, and that is from the little that we do understand about processing in mammal brains, or the very limited aspects of mammal brains, is that again the pipeline of compute over there is such that the memory and processing or the memory and compute are not isolated. They do get merged at places. So in your conventional von Neumann architecture, you would have very clearly defined instances where the CPUs or the logic units would do the math, and the memory blocks would store the results or would store the operands and so on. But this is where in nature or in more efficient computational system, the lines get blurred. So you can think of it, if you have, gigabits or gigabytes worth of memory, and every small memory block starts to compute or do some math for you, and you're not just depending on your CPU, then it just becomes massively parallel. And even though if the memory cells or the memory blocks, they do a very simple operation like an addition operation or a very straightforward compute, not any fancy non-linear compute, still the power that it would give to the entire system would be just enormous. So now the good thing is that it's not just in academia that these ideas are being pushed around. The industry is taking cognizance, and it's the even better thing is that things are actually being fabricated in hardware with some of these research paradigms that I'm going to talk about. And there are a lot of cases, whether you talk about Intel, IBM, or NVIDIA, where custom ML AI hardware with a very strong focus on how memory is behaving inside these hardware systems is coming into light, and that is a good case, and that makes the area very active and very interesting to be working into at the moment. So I'd like to make this comment that memory technology is no hype, and in fact I feel it's one of the real manifested science fictions or targets that we do envision for very futuristic engineered objects. So some of the things or man-made marvels that we cherish are like structures like these, where we say that you're packing 160 floors in a length of 800 meters. Now let's look at this. These are 128 floors packed very neatly in a dimension less than 100 microns. So, and this is a reality. This exists in your hands if you are working with the SSD, which is any solid state drive, which is reaching the capacity of hundreds of GBs or even 1 TB and upward. So these extremely engineered 3D integrated ICs or semiconductor chips are not a fancy. They are still evolving or going through the phase of maturity while we speak about logic and transistors, but in memory, they do exist even as of today. The Potkim stairs in Ukraine, and there you go again with nano vertical flash memory cells where you have very finely graded staircases making connections, taking care of all parasitics, and where you're extremely finely or in a controlled way manipulating electrons in each of these 128 floors. So this is something which is real. So that gives us more encouragement and hope to use these structures or use these devices for applications which are beyond just 1 and 0 storage. So that is one of the research vision that we follow, that memory by far has been dumb. People just use it to store ones and zeros. Let's say if we can take it beyond. So in our group at IIT Delhi, we have been exploring several different materials, and depending on the underlying material, the operational physics of the storage mechanism changes, and we come up with different flavors. When you change the material, the switching action changes. So different physical phenomena get involved. There are structures where we have redox reactions that lead to ones and zeros. There are structures where we have phase change mechanisms where you are going between amorphous and crystalline phases. There are mechanisms where we are exploiting magnetoresistive properties, or we are playing with the vacancies and defects. So in all these emerging memory devices, as we change the material, the underlying switching physics changes. And interestingly, what it leads to, it gives you many new properties, many new characteristics to play around with. And that is what we try to exploit to build new applications. Now, the traditional way for the industry has been to just get a clean 1 and 0 and stop it there. And to ignore or to mask all the non-linearities or the non-idealities as variations or variability. But what we do is we go into that scrap zone and we pick up those properties which are known to be a nuisance or a problem in the conventional industry, and we try to say, can we put them to some use? And that is one fundamental direction of how we look at things. So in our group, the different memory applications that we have been investigating with respect to the next generation memory devices are obviously, on one side, they are the conventional applications which are related to pure storage. And on the other side, that I like to call as unconventional applications, the first set of applications relate to intelligence, or that is again more compute-centric applications. So these can go for building neuromorphic systems. We have demonstrated some machine learning realizations, energy efficient realizations for CNNs, BNNs, restricted Boltzmann machines, in-memory computing or logic in memory. And then we have certain applications which are more hybrid circuits, hybrid CMOS NVM circuits. And what we do here are applications like content addressable memory, non-volatile SRAM, and more recently, even some interesting use cases on security. So hardware security or cyber physical security, where we are developing security primitives such as PUFs, physically unclonable functions, or random number generators or pseudo random number generators. So now, what is the approach that we follow in all of this is we try to follow a structured backbone. We start with materials or devices, try to extract their electrical behavior, go further modeling it in different ways, whether it is empirical, compact, or behavioral modeling, whatever the use case is. Then we start building circuits with those models. Those circuits very soon, they graduate to architectures. And that is where we can start benchmarking applications on them. And the new applications, 3 new applications that we do beyond storage are compute, sense, and security. And finally, we put these things to the benchmarking test against conventional solutions. So it's a bi-directional approach. From any of these circles, some feedback can trickle in to some another circle. So at times, what happens is that we have an application and the target is to find the right kind of device or the right kind of circuit which optimizes that application. And many times it happens is that we have a device in hand or properties of a device which are very unique, and we need to find an application to which it can be mapped. So this is a very interesting loop, and then this makes the research non-monotonous, and because we get a chance to keep going between different layers of this optimization. So I'll just take one or two quick specific cases. So when we build these neuromorphic systems, one of the key elements that we try to emulate is the biological synapse. And at a very abstract level, if you look at the biological synapse, it's we consider it, or we oversimplify it to be a programmable resistor. A programmable resistor sitting between two neurons, meaning how two neurons communicate. If the synapse is extremely potentiated, it lets the signals go through. It augments the signals that go through between two neurons. If it is depressed, it would try to block those signals. So in pure electrical terms, we look at it as a programmable non-volatile resistor, and that's where the synergy with some of these resistive memory devices or emerging memory devices start, because electronically we can manipulate their resistance states and their conductance states. So some of the characteristic problems that one needs to solve when we are trying to build these spiking brain-like systems is to see that some specific questions that we try to answer is that how many different levels or how many different weights even exist between the two extreme states. And then in device technology, what happens is there is some asymmetry depending on the physical mechanism involved. When you go from a low conductance to high conductance, in some cases it may be gradual, it may be a step function, it may be an abrupt function, and in the other cases it may be completely different. So we try to see how to solve those problems and map it to biological learning rules. The other aspect is that the neurons in mammalian brains, the action potential, by far we consider it to be identical. And so one challenge here is to get identical signals to be able to manipulate this device. So yeah, I think that is just the second case quickly that I'd like to cover is that, in the semiconductor industry, as we scale, as we go towards more nano technologies, there is the huge problem of process variability or device variability, and the devices start showing non-ideal behavior. And that is where that is considered as a problem by the industry. These distributions that you see or these broken curves that you see, the industry wants them to be ideal. But we step into these scrap zones and we try to exploit them for the different applications, because there are applications which would benefit from these kind of distributions, whether it is randomizing a weight matrix in a neural network, or it is getting a source of noise, or if you're trying to get a non-linear mathematics done, then again these kind of weird or unwanted characteristics would be of use. So this is a very interesting direction where we put to use all the properties which were disliked by the conventional industry. So with that, I'd like to conclude. And I think it's, as mentioned, it's a great time to be in this field because we are going beyond storing just ones and zeros. Deterministic behavior of the electronic devices was always being used and it is always desired. But what we are vouching for is to use probabilistic behavior, non-ideal behavior, or even stochastic behavior, meaning all the misbehavior of the devices is what we are pitching to use. And that is a significant change from the norm, because a lot of resources are spent actually to make the devices behave in a deterministic way rather than a indeterministic way. So overall playground is, it's multidimensional. You can optimize some things at the level of circuits, some things at the level of architectures. All of these go hand in hand. And memory can now be used for storage, computing, sense.
Thank you, Dr. Suri. I invite Dr. Neeraj Kumar, Principal Scientist, CSIR, Central Electronics Engineering Research Institute, Pilani, Rajasthan.
Good afternoon, everyone. First of all, I would like to thank INE for giving me this prestigious award. Now I would like to share my work with you. So I will share my slides now. I am going to present my work on high power plasma assisted sub-terahertz source, which is HP terahertz source on a plate. The aim was to develop a novel sheet electron beam driven, high power and compact sub-terahertz source. The motivation behind choosing this area was the unique properties of terahertz wave as well as its application area in the domain of communication, standoff imaging, and non-destructive evaluation application. So, terahertz technology market is expected to reach around 750 million euro value by 2023 with CAGR value of 25%. Worldwide efforts are going on in this direction. European agency, they have launched a major program named as Twitter under Horizon 2020. Even DARPA USA, they have also launched a major program named as High Frequency Vacuum Electronics, which is Hi-Fi, in the worth around 60 million US dollar in 2016. However, there are some challenges which are associated with high power vacuum electron based terahertz sources. First one is high current density electron beam generation from 100 micron size cross section. The second one is surface roughness should be less than 100 nanometer, which is highly required for efficient beam wave interaction process. Then the third one, the alignment between the component, the level of misalignment should be less than 0.1 degree between the components of vacuum electron based terahertz source. Accordingly, I have planned my work in following manner. I started with design and development of high current density sheet electron beam source, where the aim was to develop a sheet electron beam source which can generate current density more than 1 kA per centimeter square. Second one was to design and development of sheet beam driven high power plasma assisted sub-terahertz source on a plate. First, I did the simulation to compare the behavior of the electron beam in vacuum as well as plasma. Due to the presence of gas inside the drift space, beam impact ionization led to the formation of ion channel on the envelope of the electron beam, which led to focusing of the electron beam. So it got proven that due to the presence of plasma inside the drift space, electron beam can be focused. Accordingly, I have worked on different configuration of electron beam source like single gap single circular aperture, single gap multi-circular aperture, single gap sheet aperture, multi-gap single circular aperture. Out of these four configuration, what I have found that the single gap sheet aperture gives the maximum current density. So accordingly, optimization has been carried out for this sheet electron beam source like the parameters of hollow cathode diameter to length ratio, diameter, which is the hollow cathode diameter, then length, its length of hollow cathode, which found to be around 30 mm, then aperture aspect ratio, where the sheet aperture length to width ratio, it's around 5:1, sheet aperture size 1.25 cross 0.25 mm, then wall aperture radius, because for uniform field penetration, you require a smooth wall curvature, which is found to be around 0.5 mm. Wall aperture thickness 1 mm. Beam adapter circular to sheet. Accordingly, a high current density sheet electron beam source has been developed, and the aperture size is 1.25 means 1250 micron cross 250 micron, and the generated current density is 1 kiloampere per centimeter square. This is the patent which has been granted on this particular work, and the patent title was sheet beam plasma cathode electron gun for the generation of high current density sheet electron beam. Another challenge was to development of beam wave interaction structure with surface roughness less than 100 nanometer. I started with first micro-EDM based fabrication, but the problem was the tip of the electrode was getting eroded during the operation of fabrication. So then I switched to micro milling based fabrication process. This is the first image for initial trials, and then finally the milling parameter got optimized, and this is the structure which has been developed after so much optimization of the micro milling parameter. And these are the tool parameter of milling value. These are the optimized value like spindle speed, tool diameter, tool milling path, flute length, tool feed rate. And this is the finally developed interaction structure with least dimension of 269 micron, and the achieved surface roughness is well within very less than 100 nanometer. Then the another challenge was the level of misalignment should be less than 0.1 degree between the terahertz sub-terahertz source component. So what I did, I conceptualized this design process where all the major component of the terahertz source, has been developed on a single plate, and the dimension which achieved as compared to the designed value is less than 7 microns. So the maximum achieved dimensional deviation was less than is around 6 micron, and the level of misalignment, which is much less than 0.1 degree, is to 0.02 degree. And these measurements all have been carried out at CSIR Siri as well as our sister lab CSIR NPL, and it has been again confirmed from one private firm. Filed a patent on this, titled as a technique for integration of component for realization of compact sub-terahertz source backward wave oscillator. Very recently it has been filed, and the important step is that the cited document where this patentability report has been compared, this L1, D1 and D2 are of international origin. So all this means the novelty has been compared with the international level patents. Finally, this HP terahertz source on a single plate has been developed. This is the top view, this is the front view, this is the cold test measurement, and this is the actual setup with the HP terahertz source and the receiving module, and this is the hot test of this terahertz source. The novelty and impact of this particular work is high current density sheet electron beam source has been designed and developed for the first time. A novel technique for fabrication of component of HP terahertz source on a plate has been developed for the first time. These are the features of this technology: with peak power more than 100 watt, bandwidth more than 12 gigahertz due to the presence of plasma, tunability. It can achieve by changing the applied voltage from 10 kV to 30 kV. Pulse width may vary from 25 nanosecond to 1 microsecond, and the pulse repetition rate, it can go up to 5 kilohertz maximum, and scalability of such kind of source can go up to 0.85 terahertz. And application area in strategic domain, it's imaging, plasma diagnostic. From industrial side, it can be usable for communication and non-destructive testing. These are some achievements related to these works. Recently, a letter of appreciation from DAE IPR Gandhinagar has been received for development of this high current density sheet electron beam source. Then one industry is also interested for joint collaborative work in this particular area, Messrs. Sajanan Technology. Then even INE has recognized as a future technology, terahertz technology. So they have given a sponsored project to Siri, where Siri is the coordinating agency. So where we have to make a technology roadmap proposal. So these are the details of my work. I would like to once again thank INE, and thank you everyone. If you have any query and suggestion, I will be happy to answer. Even you may also write to me on this email ID. Thank you.
Thank you. I invite Mr. Pushkar Varshne, Senior Research Manager, Indian Oil Corporation Limited, Research and Development Center, Faridabad.
A very good day to all the esteemed members of Indian National Academy of Engineering and the viewers joined virtually. Myself, Pushkar Varshne, Senior Research Manager, Indian Oil Corporation Limited, Research and Development Center, Faridabad, Haryana. The topic of my today's presentation is Optimax, an indigenous technology for conversion of cracked C4 stream to high-octane gasoline developed by Indian Oil R&D Center. The scope of my today's presentation is development and commercialization of Optimax technology for production of BS6 gasoline. First, I would like to mention the genesis for the development of this technology. This technology was developed by IOCL R&D Center in the backdrop of challenges faced in the production of BS6 gasoline, which was implemented throughout India since April 2020. The main specification of BS6 gasoline is sulfur content, which is 10 ppm. Earlier it was 50 ppm in BS4 gasoline specification. The other specification of BS6 gasoline is aromatic content of 35 volume percent, olefins content of 21 volume percent for normal grade, and the 18 volume percent for the premium grade. The other major specification of BS6 gasoline is the octane number, which is 91 for the normal grade and the 95 for the premium grade of gasoline. As you are aware that the gasoline is a blend of various streams in the petroleum refinery, such as FCC gasoline, reformate, isomerate, and alkylate. There are problems associated with each of these streams while meeting BS6 gasoline specification. For example, in case of FCC gasoline, this stream has a moderate octane number and there is a drop in octane due to the deep desulfurization required to achieve the sulfur level of 10 ppm. Besides this, it also contains very high amount of olefins. The second stream is reformate. The problem associated with this stream is a high aromatic content in the range of 70 to 80 volume%, while the specification is 35 volume% for the BS6 gasoline. In case of isomerate, the problem associated with this is higher feed vapor pressure and the low octane. Further, a high investment cost is required for enhancing the octane number of the isomerate. The fourth stream is the alkylate. Environmental issues are concerned with this due to the use of highly corrosive sulfuric acid and the hydrofluoric acid. In view of this problem associated with this various streams for the production of BS6 gasoline, there is a need for the development of technology which can provide an high octane gasoline blending component with a low investment cost and the environmental friendliness, with the objective of requirement of cost effective and eco-friendly technology for production of high octane gasoline blending component. A technology named Optimax was developed by Indian Oil R&D Center. This technology converts cracked C4 stream to high octane gasoline blending component. The feed for this unit was obtained from the cattle cracker units such as FCC, RFCC or naphtha cracker. The LPG from catalytic cracker unit after separation in C3-C4 splitter constitutes the feed for this Optimax unit. The product from this unit is having a very high octane number. It is more than 110, and the unconverted C4 stream which do not react in this Optimax unit is routed to the LPG pool. The main reaction in this technology is a dimerization reaction, where in which two molecules of isobutene dimerize to form one molecule of isobutene, which is C8 olefins. This technology employs solid heterogeneous catalysis as against the toxic homogeneous catalysis employed in the alkylation technology. As I earlier mentioned, hydrofluoric or sulfuric acid is used in alkylation technology. The operating condition of Optimax technology is very mild. The temperature is in the range of 40 to 100 degrees centigrade and the pressure is in the 10 to 16 bar. Now I would like to describe the chronology of Optimax technology development from concept to commercialization. First, the idea was conceived and a proof of concept was established using pure reactant. In our case, it is isobutene, by conducting experiment in the microreactor unit. Then in the lab development stage, experiments were conducted using synthetic feed whose composition is similar to the actual refinery stream. A bench scale unit was also set up during this stage, having a facility for handling of C4 liquid feed as well as the characterization of product, which is a mixture of dissolved C4 in the liquid product. This stage followed by the commercial feasibility stage, in which demonstration and validation of the process was carried out in the bench scale unit using the actual refinery C4 stream, which also include the effect of various contaminants In this stage, a long duration experiment was conducted to validate the process scheme. The next stage is a commercialization stage, which is the most critical one. This stage involved setting up of the first Octamax unit with a production capacity of 55 KTA in Mathura refinery. Various activities such as process scheme development, BDAP was carried out. After successful commissioning of this unit, we have improvised the process scheme based on the learning obtained. A second unit of capacity 110 KTA is also going to set up in another refinery. Now coming to the unique and innovative feature of this technology, which is the in situ production of promoter alcohols. In this technology, besides dimerization reaction, several other side reactions also take place, which is mainly oligomerization reaction, which lead to the formation of undesired heavier oligomers. So these promoter alcohol minimizes the formation of the heavier oligomers. These promoter alcohol is produced in a separate hydration reactor on continuous basis. A very precise quantity of these alcohols are produced in a separate hydration reactor, which obviate the requirement of any recycle section. A patent of this technology was filed in India and other countries. The patent was granted in USA, Europe and Saudi Arabia. Now I would like to describe the various activities involved in the commercialization stage, which is the most critical one. As mentioned in my previous slide, a commercial unit of 55 KTA capacity was set up at Mathura refinery based on this technology. The main activity in this commercialization stage is the development of BDAP, the basic design and engineering package. The basic design and engineering package for this unit was developed in-house without help of any external agency. Various activities were carried out, such as finalization of process scheme, development of reactor model, simulation of whole process scheme in Aspen HYSYS, development of process flow diagrams, process instrumentation diagram, followed by design of critical equipment such as heat exchanger, reactors, distillation column, and HAZOP study. After the preparation of BDAP, we have estimated the cost of the unit for getting the required approvals. After getting the required approval, the procurement and erection of various component mechanical parts were carried out, and the unit was installed and commissioned in January 2018. Now I would like to describe the process flow diagram of this technology as shown in the slide. The technology consists of two sections. First is the reactor section and the second is the separation section. In the reaction section, two types of reactors are employed. The first is the hydration reactor, as I mentioned, for the production of promoter alcohols, and the two other reactors are dimerization reactor, which are operated in the lead and lag position. In the separation section, we separate the unconverted C4 and the main liquid Octamax product. A portion of the unconverted C4 stream was recycled back to the dimerization reactors to control the exothermicity in these reactors. Considering this very low and simple configuration of this technology and the moderate temperature pressure employed in this technology, the capex and opex requirement is very low. Coming to the techno-economic analysis of the first unit based on this Octamax technology at Mathura refinery, the approved cost for the unit was 44 crore rupees. However, the actual cost incurred on this project was 33 crores. The project was started in 2016 and was executed in 28 months. With the successful commissioning in January 2018. The pie chart shows here indicates the pool composition before and post Optimax unit. The blending of Optimax product in a very small proportion leads to the increase in gasoline production by 63,000 metric ton per annum. The net benefit of 27 crores per annum was obtained at Mathura refinery, which leads to the payback period of less than 15 months. If you look the performance of this unit, the actual research octane number of the product from this unit was more than 120 after the commissioning of the unit against the guaranteed run of 108. At Mathura refinery, we are able to upgrade the low value naphtha by addition of this Optimax product. As I mentioned in my previous slide, we have improvised the process scheme based on the learning obtained from this first commercial unit. We have filed an process patent on the revised process scheme. Now to summarize, I can say that Optimax is a need of the hour, economic and eco-friendly technology for the production of BS6 gasoline component from the cracked C4 stream. It is first of its kind and no similar unit is there in India in any of the refinery. First of its kind, the project of this type of project was executed by IOCL R&D Center with complete indigenous effort, which showcase that it is a true spirit of Make in India. Further, we have launched a niche product XP100 using this technology. As I mentioned earlier, a second unit of 100 KTA is going to be set up in another refinery, and third unit is under active consideration by one of IOCL refinery. Our group and myself is also involved in the development of light naphtha isomerization technology in addition to this Optimax technology, where we have developed an catalyst activation procedure, and similar to this catalyst sensitivity study, we have also filed a patent on this new process scheme for the light naphtha, and the commercial demonstration of this undergoing technology for the light naphtha isomerization is under active consideration at one of IOCL refinery. So I thank all of you for your kind patience and listening to my presentation. Thank you very much.
Thank you. Award winners of INAE Young Innovator and Entrepreneur Award 2021. I invite Dr. Chandan Kumar Jha, Postdoctoral Fellow, Indian Institute of Technology, Gandhinagar, specialized in the field of fiber optic sensing for development of highly sensitive and reliable instrumented glove.
So in this presentation, I'll be talking about some applications of fiber optic sensors for healthcare. The fiber Bragg grating sensors, or FBG sensors, have been well known for years and are widely in use currently, mostly for structural health monitoring applications. The photographs you see here are that of FBG sensors. Now, one special advantage that these sensors provide is multiplexing capability, which means that multiple sensors can be inscribed on a single fiber, and each sensor being able to detect a different entity, such as strain, temperature, pressure, voltage, etc. Now, this makes multi-point and multi-parameter sensing very convenient. And there are several benefits of using FBG sensors, specifically for healthcare applications. They're very small in size, as thin as a human hair, and they are biocompatible, so they can be used for sensing inside the human body. And they are highly sensitive to both strain and temperature. As a consequence, these sensors can be used to detect multiple entities, such as human voice, movement, vibration, and temperature. So these sensors are also immune to electromagnetic interference and therefore ideal for use in hospitals and places where machines such as MRI are used. So these sensors are constructed by periodically modulating the refractive index of the core of an optical fiber, And this index modulation makes the fiber behave as a wavelength selective mirror. So when a broadband light is launched into this fiber, a narrow band of light is reflected, and the remaining light is transmitted. So the center wavelength in the spectrum of the reflected light is called as Bragg wavelength, which varies with the grating period of the FBG. So when there is any perturbation in the fiber, the the grating period changes, which in turn shifts the Bragg wavelength. And by accurately detecting this Bragg wavelength change, we can determine the amount of perturbation caused. So during my PhD at IIT Gandhinagar, I worked on developing a highly sensitive instrumented glove to measure finger joint angles using these FBG sensors. And these sensors made the glove very lightweight and also enabled measuring finger joint angles with very high accuracy and precision. The design of the sensing system was very simple. An FBG sensor coupled to a spring with a very low spring constant. And this unit is attached on a finger. The spring side is fixed on the palm side, while the fiber is attached on the digit following the joint of interest. So when the finger is flexed or extended, the FBG sensor is stretched, causing the strain in the FBG. And this strain changes the Bragg wavelength. And by determining the change in the Bragg wavelength, the joint angle is determined. So this is how our first design of the sensor unit looked like. And then we placed multiple of these on a commercially available Lycra glove on which we had attached 5 strips of PVC latex foam, and then 10 FBG sensor units were attached on these strips. So 5 units were attached towards the dorsal side of the palm to measure the MCP joint, while the another 5 were attached on the digits following the PIP joint angles to measure the PIP joint angles. So an additional layer of Lycra fabric was also attached onto this glove to secure the sensors onto their positions. And the photo that you see here shows the front and the back view of the final glove prototype. We also stitched a zipper to the glove to make it easy to wear and remove for stroke patients who have disability in their hand. Now, this is how our glove looked like. The FBG sensors are now multiplexed on using a optical splitter here, and you can see all the 10 sensors are now on a single optical fiber, which can be connected to a FBG interrogator. And the interrogator measures the Bragg wavelength from which the finger joint rotation angles can be determined. Using the glove, we can measure the finger joint angles with a resolution of 0.1 degree. One important feature of this glove is that the sensor response is linear, and because of which the sensitivity is uniform across the complete measurement range. And this makes calibration a very easy and simple routine. So to calibrate the sensor, the user only needs to place his hand in any 2 different positions. Now, this is not the case with other popular sensors like the resistive bend sensors, whose response is nonlinear. So in this graph, the output voltage of a resistive bend sensor is plotted against the rotation angle. And notice the response is nonlinear. Therefore, the sensitivity is also not uniform. And the sensitivity for lower angles is almost 0, which means that the sensors cannot accurately measure lower angles. And the calibration is also therefore not straightforward. For instance, the calibration of cyber glove, which uses resistive sensors, can take up to 30 minutes. This photograph shows the virtual rehabilitation platform that we developed using our FBG glove. So the glove is connected to an FBG interrogator, which is further connected to the controller module. And the controller module creates a Wi-Fi hotspot using which a mobile device like a tablet or a smartphone or a VR headset can connect to the glove. The virtual reality application which runs on the mobile device can then be controlled using the glove. So let me quickly show you the system in action. So here I'm wearing the glove. Now I'll calibrate the glove by putting my hand in two different positions, which we call as flat and flex. And now the glove is calibrated. And after this, we can launch any virtual reality exercise games that can be played using the glove. So here is one such game which is being played using the glove by bending the fingers. Okay. So we developed this system specifically to assist stroke patients in hand rehabilitation. Now, a key advantage of the system is that the assessment of recovery progress and movement quality can be very accurately performed during the therapy session itself. So currently there are many techniques such as box block test, FMA, ARAT that are used to assess the recovery progress in stroke patients. However, these tests are largely subjective, they are imprecise, and often tedious to perform. On the other hand, using the virtual rehabilitation platform such as ours, the assessment can be done while the patient plays virtual reality games. And continuous monitoring of finger movement that can be done while playing the game enables to provide feedback to the patient to correctly perform the exercises and provide reports on recovery progress. In this video, my friend is playing a game using the glove. What is interesting is that from this simple game, several important parameters can be derived that can be used to assess the stage of disability and the recovery progress made by the patient. So for example, the reaction time of the patient can be calculated by determining the time the ball enters the hit zone and the time when the user starts to bend his finger. Now, several studies have shown that the stroke patients have high reaction time, and such information therefore may help the physiotherapists or doctors to assess the condition of the patient in much more objective way. To take this research to the market, I have found a startup named Gallant Innovations Private Limited. We are a team of 6 people motivated to advance the rehabilitation technology in India. And in this pursuit, we have presented our idea at several prestigious venues and won several awards, appreciation, and useful feedback. We are working on this feedback to take the next steps. One another interesting application of FVG sensors is to detect human voice. As FVGs are highly sensitive, they can detect even whispers in very noisy environment. And these sensors could therefore be useful to develop communication devices to communicate with patients during MRI scan, where the amount of noise is very high. At IIT Gandhinagar, we used FVG sensors to detect voice from the neck region. The sensor is fixed on a silicon strip and then attached onto the throat using a medical tape. Currently, we are trying to improve the design to make it easy to wear and remove the sensor. What is interesting is that the FVG sensors greatly suppresses background noise and selectively picks up the human voice. So we performed an experiment in which we recorded some speech samples in presence and absence of very loud noise using a high quality microphone and the FVG sensor. Now in this graph, the black trace is the signal recorded using the microphone in absence of noise, and the blue trace is the signal recorded in presence of noise. Now clearly we can see that the speech signal is buried in the loud background noise. However, in case of the FVG, we can see that there is very little amount of noise in the signal that is recorded even in presence of noise, which means that using FVG sensors, we can communicate even in presence of loud background noise. So in this video demo, we will show that the contact microphone that we have developed using FVG sensor suppresses the background noise to a great extent, and in this demo, I'll first be recording some speech while a loud background sound is being played. I will then stop the background sound and the recording and play the sound that has been recorded by the FBG. And then we can notice the noise suppression offered by the FBG sensor. So this is the sound after applying a very simple filter, and we can see that the sound quality is very nice. The background noise is suppressed to a great extent, and this can be used to develop several communication devices which could be used with MRI system or any other place where there's a lot of background noise. So in summary, the FBG sensors show great potential for applications in healthcare, particularly because of the high sensitivity, biocompatibility, immunity to EMI, and multiplexing capabilities. Several researchers around the world are trying to develop multiple sensors to use FBG for biomedical applications. The cost of the FBG interrogation system, however, has been a bottleneck in large commercial applications. But with advancement in technology, the cost of these units is decreasing, which will speed up the development and implementation of FBG-based sensors. So with this, I would like to end my presentation. I thank you all.
Thank you. I invite Dr. Madan Balaraman, Senior Principal Scientist, CSIR, Central Leather Research Institute, Chennai, specialized in the field of leather technology for development of collagen composite scaffold for treatment of wounds.
I thank President and Executive Committee of Indian National Academy of Engineers for my selection to the INAE Engg Innovator and Entrepreneur Award 2021, and also for giving me this opportunity to make a presentation about my work on the development of collagen composite scaffold, which are used for the treatment of chronic wounds. Today in India, more than 77 million people are affected by diabetes. With such a huge population afflicted by diabetes and associated neuropathy, is resulting in the increase of wound burden for the country. In fact, every 30 seconds, lower limb is lost somewhere in the world, which is mainly due to the diabetic foot ulcers. Further, there are 3 million leprosy cured but deformed personnel whose life is impacted with chronic wounds, and several million patients have wound complications due to various other conditions, including a huge burden associated with bed sores. So the average cost for the treatment of a chronic diabetic ulcer in the West would be anywhere greater than $20,000, which as a country in India, we cannot afford. And hence there is an imminent need for the development of affordable and effective advanced wound care solutions. Collagen is a major protein present in skin, bone, tendons, cornea, and many other connective tissues. The collagen sequence that is present in bovine, marine, and human, they are more or less the same. And therefore, collagen extracted from an animal source is highly suitable for human application. And as a protein, collagen elicits very minimal antigenic response. And the other major advantage of collagen is that it can be processed into different forms. It can be made into sponges, powders, fleeces. And therefore, collagen, when we make as a biomaterial, it provides great advantage to, one, outsmart the body's defense mechanism, and two, to provide appropriate scaffolding character, so which is effectively used for the treatment of chronic wounds. Some of the materials that are currently available in the market, which gets absorbed quickly. So therefore, in order to make the collagen-based biomaterial to be effective, strategies such as composites, collagen-based composites were attempted by our group. And so basically, by bringing in other composites, we can improve the mechanical handling ability of the material. And most importantly, the collagen dressings, which are used for the chronic wound healing applications, they requires frequent change. And that depends on the nature of the wound. If it is a heavy exudating wound, the dressing have to be changed almost sometimes even twice a day, and sometimes once in 2 days. It varies. And collagen acts as a sacrificial host. At the wound bed, there are huge amount of MMPs upregulated, which has the ability to break down collagen quickly. So therefore, if we are in a position to control the absorption of collagen biomaterial at the wound bed, we can prolong its usage. And we have used other biopolymers such as chitosan and natural molecules in order to control the turnover rate of collagen and also bring in other characteristics to promote the healing of chronic wounds. So in our lab, we had made materials based on biomolecules such as capsaicin, curcumin, which we found out to be effective for the treatment of wounds. But all these collagen sponge, one of the limitations is that we cannot have a higher load of collagen, because when we make sponge, we can have only about 5 milligrams of collagen soluble in per ml of the solution. Whereas when we fragment collagen into smaller peptides, we will be in a position to enhance its solubility beyond 100 milligrams per ml. So that therefore, when we make a sponge, the collagen load can be higher. So therefore, the therapeutic efficacy brought in by collagen, which acts as a domains to stimulate the growth of fibroblast cells. And the fibroblast cells are the ones which in turn produce collagen and which can support the remodeling of tissues at the wounded site. And we also found that by using a scratch assay, we find these collagen hydrolysates, which have been enzymatically prepared, fragments of collagen, to be much more effective in terms of allowing the growth of fibroblast cells. It was observed to be better than collagen. And therefore, by making a material based on the fragmented collagen and by combining with other biopolymers such as chitosan, we could make an effective sponge which had the appropriate porosity, which is another important requirement for an effective scaffold which can be used for soft tissue engineering applications. And just to illustrate some of the global best brands of collagen biomaterials, there is BioStep from Smith & Nephew, Fibrocol Plus, which was originally from Johnson & Johnson and currently being done by Centagenics, Purocol. So there are wide range of collagen-based biomaterials, and we tested the collagen composite scaffold developed in my lab against some of the world best multinational brands, and we find the collagen composite scaffold to heal the rats much faster. Now, what you see here is a rat model where we create a 2 by 2 centimeter full thickness incision wound, and we monitor the progress of wound healing over the period of 15 days. And you can clearly see here, collagen composite scaffold gets completely healed in about 15 days. The developed material through in vivo wound healing model studies was observed to be effective compared to the world leading brands of collagen scaffolds. Therefore, the developed technology is effective as well as could be made at an affordable cost. In 2015, the technology was licensed to a startup, Synerhill Pharmaceuticals. So as it happens for any startup, for Synerhill also, it took nearly 2 years to have these products commercialized. The products were launched into the market in 2017. By then, two of my PhD graduates, Dr. Satish and Dr. Satyamurthy, have become part of Synerhill team as technopreneurs to carry forward the dream of providing affordable, innovative healthcare solutions. The products got commercialized in 2017, and the products are available in the brand name C-Skin Sponge, and the sponge is made into particles, and sponges are used for heavy exudate wounds, and particles are being used for deep wounds. And the advantage of particles is it can take the shape of the wound. In order to illustrate, here in this slide, you are able to see the effectiveness of the product, which were in a position to heal chronic wounds of leprosy cured but deformed personals who had a wound history of more than 5 years, which could heal in a matter of 30-40 dressings. And in some cases, even within 5 dressings, the wound were able to heal completely. So this is the kind of impact these materials could create in the life of the affected people. And these collagen materials has touched the lives of several thousands of people affected by chronic wounds. More than 30,000 units of collagen sponge and 60,000 units of collagen particles have been sold in the market as of May 2021. So the very fact that the sales had been increasing 40 to 50% year on year until March 2020, and of course the COVID impact had slowed down the growth. Of course, now I am given to understand. So now they have crossed the pre-COVID levels. The lower frequency of dressing, faster healing, and the cost of product being lower. So therefore, the overall treatment cost reduces several folds. So the impact of the innovation is, one, the successful establishment of a startup, and it is suitable for the treatment of wide range of wounds and clinically benefited several thousands of patients affected by chronic wounds, and making available an effective and affordable advanced wound care material and ease of application of the products for the treatment of wounds. And certainly the scaling efforts in the future would lead to further increased affordability, accessibility, and can definitely impact on the lives of several hundred thousands of patients affected by chronic wounds. So thereby averting amputations and reducing the wound and social burden of the country. So many of the clinicians who have used have highly appreciated of the products. I would like to showcase here some of the feedbacks provided by the clinician.
சிலது நல்ல கண்டுபிடிப்புகள் வந்துக்கிட்டு இருக்கு. CLRI அவங்ககிட்டேருந்து வந்த கொலாஜன் தெரப்பி இதெல்லாம் வரும்போது சந்தோஷமாக இருக்குது. எனக்கு டயபெட்டிக் பேஷண்ட்ஸ், இதை போல் ஆறாத புண்கள் இருக்கிறவங்க, வெரிகோஸ் வெயின்ஸ் அண்ட் அல்சர்ஸ் இதெல்லாம் வர்றவங்களுக்கு இது ஒரு பெரிய வரப்பிரசாதமாக ஃப்யூச்சரில் அமையும்.
இவங்க பேர் ருக்மணி, ஏஜ் வந்து 80. இவங்க காலில் வந்து சின்னதாக புண்ணு வந்தது. அது ஆறவே, சுகர்னால ஆறவே இல்லை. ஸ்கின் வந்து ப்ரொடெக்ட் பண்ணக்கல சரியாகும் அப்படின்னு சொன்னாங்க.
So it has given very good results for our patients who are supposed to go for skin grafting. Diabetic patients, the wound healing is a major problem, and we can use this skin collagen instead of doing just the dressing. It is very economical compared to the international brands.
With collagen, very effectively, very efficiently, over a period of time, the wound got healed to the utmost satisfaction of all other family members. She is 80. This is the photograph of the wound. You can just see the photograph. How the wound was very, very bad, and you will be stunned to see the photograph of the wound after the treatment. He has really touched all the family members. May God give him enough strength to touch the lives of many people who deserve service like that.
மேக்ஸிமம் ஒரு 4 வருஷத்துக்கு மேலே அந்த பொண்ணு எங்கே போய் ஆறலை. சிஆர்லேருந்து வந்து அவங்க டாக்டர் 2 பேர் வந்து அவங்க இந்த கொலாஜன் மருந்து கட்டினாங்க. எனக்கு ஒரு 6 வாரத்தில் கால் கிளியர் ஆயிடுச்சு.
Chronic wounds of several leprosy cured but deformed personnel have been completely healed by using the collagen technology developed from my group. And I take this opportunity to thank all my PhD graduates and the postdoctoral researchers who have been associated with me. And I also thank a team of Synerheal for making this technology to reach out to the common man. Thank you.
Thank you. Ladies and gentlemen, that brings us to the end of INAE Annual Convention 2021. We hope you enjoyed the proceedings, and we look forward to seeing you again during Annual Convention 2022, in person or virtual mode as situation permits. Thank you and Jai Hind.